Okay, so I'm sorry I'm not here today, but we are doing two theorems today that are pretty important. The angle bisector theorem and the side splitter theorem. Um, First of all, the angle bisector theorem seems to sound pretty legit. It says if an angle bisector of a triangle divides the two opposite sides into two segments that are proportional to the other two sides of the triangle. So if this segment CD is an angle bisector as indicated here, it sets up two proportions that would be equal. X is to W should be in the same proportion as Y is to Z. Okay? These two segments should be in the same proportions as these two segments if this is an angle bisector. So for example, I have an angle bisector here drawn CD. 18 is to 12 should be in the same ratio as 24 is to x. Well, you can cross multiply. 18x is equal to, let's see, 12 times 24, because it's, and let's see, 12 times 24, 12 times 24, that's 288. So I have 18x is equal to 288. To solve for x, I'm going to divide both sides by 18. And 288 divided by 18, x should be 16. Okay? So I drew these nice arrows in here for you, but will they always be drawn? And the answer is no. You have to recognize that if this is an angle bisector, that's what happens. So for example, I have clearly an angle bisector. This line segment here cuts this angle into two congruent segments. Well, that results in two corresponding sides to be in the same ratio. So 15 is to negative 1 plus x, as 35 is to 21. So we're going to cross multiply here. I have 35 times negative 1 plus x, and I have 15 times 21. I have to make sure I distribute this negative 35 to both terms. So that's negative 35 plus 35x, that's a 3, sorry. And 15 times 21, well, that's 315 if you're using your calculator. So if I add 35 to both sides, I get 35x is equal to, oh, that's 350. If I divide by 35, x should be 10. Again, the hard part is recognizing that this is an angle bisector. And that's only indicated because these two angles have to be equal to each other. Okay? So it says in the triangle below, I have sides of 8, 12, and 15. The angle bisector meets the side length of 15, and I have x and y as my two segments. Find both x and y. Well, two variables, well, then I probably better have myself two equations. So your first initial equation, I think, would be 8 over x, angle bisector, equals 12 over y. But I'm not going to get very far at that because I have two variables. But what do you know about x and y? They add up to 15. So x plus y equals 15. There's my two equations. Here's one, here's the other. Well, I'm not going to get very far here unless I solve this. So why don't we solve this for y? I like solving for y. So y is equal to 15 minus x. Oh, yeah, I see that. And then let's take that and substitute it in here for y. So I'd have 8 over x equals 12 over 15 minus x. Oh, that seems like something I can solve because I have only one variable. So I have 8 times 15 minus x, and 12 times x. I have to do 8 times 15, which is 120, and 8 times negative x, which is negative 8x, is equal to 12x. And then I'm going to probably add 8x to both sides. And then I have 120 is equal to, oh, that's 20x. If I divide, whoops, by 20, Mrs. Lenhard, she's getting ahead of herself. If I divide by 20, 120 divided by 20 gives me x equals 6. Have I answered the question? Oh no, it wants me to find both x and y. So y is equal to 15 minus 6. So y is equal to 9. Okay, again, just because they tell you this is an angle bisector is the only reason that you know that you can set up that proportion. Okay, but if you've got two variables, you need two equations. The first, the sides have to be in proportion, and the second is, well, x plus y gives me a total of 15. Okay. The second theorem that we need to discuss and or work on is what we call the side splitter theorem. Okay. The side splitter theorem says that if a line intersects two sides of a triangle and is parallel to them, this is the key. These have to be parallel. Okay. And it's parallel to the third side, then it divides these two segments proportionally. In other words, AD and AE are broken up into the same proportion. X is to Y as Z is to W. That does not say that B and C are midpoints. Nope. Just says any points that intersect in a triangle. And as long as it is parallel to that third side, these two are broken up into sides that are split in the same proportion, right? So that when it comes to question number 1 or example number 4 here, I have two parallel segments, this and this, so that I can say, well, 5 is to 5 as 7 is to x, right? Well, you know and I know that 5 over 5 is 1, so 7 over 7 would be equal to 1, but I can also prove it by cross multiplying. So 5x is equal to 35. Therefore, if I divide both sides by 5, x has to be 7. But Mrs. Lenhard, if they're parallel, couldn't I draw them as two separate triangles? Oh, you can always draw them as two separate triangles. I need a triangle. I think I'm going to have to draw them. So if I have a triangle here, which represents the big triangle, and then I have here, which represents the small triangle, yes, can I write a proportion where 10 is to 7 plus x as 5 is to 7? Does it matter if I do it using two similar triangles? Nope, that doesn't matter. I can use these two triangles and say 10 is to 5 as 7 plus x is to 7. I'm going to get the same answer. Okay? Well, look at this. Again, I have two parallel sides, and I know that this distance is x and this distance is x plus 12. This distance is 11. Oh, wait a second, I don't know that distance, but I know that the whole segment is 33. So this piece would have to be 22. So now I can set up a proportion. X is to x plus 12 as 11 is to 22. So I'm going to cross multiply, and I'd have 11 times x plus 12. Folks, notice when I cross multiply and I multiply by a binomial, I always put it in parentheses because you have to distribute that 11 to both terms. And 22 times x is 22x. So I have 11x plus 132 is equal to 22x. If I subtract 11x from both sides, I have 132 is equal to 11x. If I divide by 11, 132, x is going to be equal to 12. Okay? So that corollary to that is that if I have more than one set of parallel lines, 3 or more, and they intersect two transversals, then they divide them proportionally, like this diagram, because these lines, if these lines are all parallel, then these segments here and here of these transversals should be broken up proportionally. So 2 is to 8 as x is to 12, right? They should be broken up in the same ratio or proportion. So 8, if I cross multiply, I get 8x is equal to 24. And if I divide by 8, x is 3. Okay? All right, so those are today's notes. I think you can start working on your tonight's homework. And don't forget to work on your cumulative review number 10, which is due next Friday. Have a great weekend.